The dashboard is green. Every unit test passed. The release candidate cleared the checks its builders wrote for it. Now imagine that the system is not merely summarizing a document. It is identifying an opportunity, explaining a trend, and recommending what someone should do next. Here is the uncomfortable question. What exactly did those green tests prove about the recommendation the system will produce tomorrow? In a production context, the test suite may never have represented. That question is narrower than the title many people would instinctively write. The supplied findings do not document an AI hallucination in production. They do not describe a model passing its tests and then causing an incident. They do not compare unit testing with another testing method. So this is not evidence that unit tests are failing. It is an investigation into the size of the claim we attach to a passing result. A green test is real evidence. It tells us that a defined check ran and produced the expected result. That matters. But the color green does not tell us, by itself, how representative the selected inputs were, which variations were excluded, or whether the expected outcome captured every behavior that matters in production. The first distinction in this story is therefore simple. A test result and a production guarantee are not the same object. Why does that distinction feel more urgent now? Because the role assigned to AI is changing. OpenAI highlighted newsroom agents that identify business opportunities, explain trends, and recommend actions rather than merely summarizing information. Listen to the verbs: identify, explain, recommend. Each verb moves the system closer to influencing what a person or organization does next. A summary can still contain an unsupported statement. That would be a reliability problem. But when an unsupported statement becomes part of a recommendation, the concern gains another layer. The output may help determine which lead receives attention, which trend appears important, or which action seems justified. The verified finding does not say that any such failure occurred. It does show why the reliability question changes when an AI output is designed to guide action. Now stop at the evidence boundary. What do we actually know about hallucinations from the supplied findings? No rate, no incident count, no benchmark, no documented financial loss, no description of test coverage, no record of a unit test missing a specific failure. Those absences are not minor footnotes. They determine which story can honestly be told. We cannot say, as a factual conclusion, that conventional unit tests are failing to catch AI hallucinations in production. We also cannot say they categorically cannot catch them. A carefully chosen test could detect a problematic output for a particular input. The record supplied here simply does not measure how often that happens or how far that protection extends. So the evidence creates a question without answering it. If AI is being asked to recommend actions, what kind of confidence should a passing set of selected cases provide? That is a legitimate engineering concern. Turning it into a reported failure would cross the line between interpretation and fact. Consider a release review. On one side of the table is a list of checked cases. Each has an input, an expected outcome, and a result. On the other side is a much larger claim. This system will behave reliably across future users, contexts, requests, and decisions. The temptation is to let the certainty of the first list transfer to the second claim. But that transfer requires evidence of its own. This is where scale matters as a concept, even though the supplied findings do not give us a verified adoption statistic for this story. The more workflows a system enters, the more varied its operating conditions may become. That statement explains why deployment scope matters. It does not establish how frequently hallucinations occur or prove that any named company has experienced one. The key consequence is not that scale automatically makes a system unreliable. It is that a broad reliability claim must cover more ground. A test suite can remain useful while representing only a bounded portion of that ground. If builders say, "These cases passed," the claim matches the evidence. If they silently translate that into the system cannot hallucinate in production, the claim has expanded beyond what the supplied record establishes. And here is the midpoint turn. This is not a story about broken tests. It is a story about oversized conclusions. A unit test has a defined job. It checks selected behavior under selected conditions against a selected expectation. When it passes, it has done something valuable. The problem begins when people ask that bounded result to answer a different question. What will happen across every future context in which the AI may be asked to explain a trend or recommend an action? Picture a boundary map. Inside the boundary are the inputs that were chosen, the expected outcomes that were written down, and the behaviors the suite actually checked. At the center is a green badge marked pass. Outside are other contexts, other phrasings, other source material, and broader claims about future behavior. The map does not predict failure outside the circle. It shows where this particular evidence stops. That distinction protects us from two opposite mistakes. The first is dismissing testing because it cannot prove everything. That would throw away useful evidence. The second is treating passing tests as a universal verdict. That would inflate useful evidence into something it never claimed to be. The OpenAI finding makes this boundary more consequential because the agents described are action-oriented. If a system identifies an opportunity, explains why it matters, and recommends a response, then several different behaviors may require scrutiny. Did it represent the source material accurately? Did the explanation introduce an unsupported premise? Does the recommendation follow from what was established? Those are questions raised by the role of the system. The supplied finding does not tell us whether any particular test suite answers them. This also explains why merely counting green checks is not enough to describe confidence. 10 tests can be broad or narrow. 1,000 tests can still encode repeated assumptions. Those statements are illustrations of logical coverage, not statistics about real systems. The important question is not only how many checks passed, it is what reliability claim those checks are capable of supporting. Return to the opening dashboard. Every test is green. What has been proven? The behaviors represented by those tests met their defined expectations under the tested conditions. That is the precise answer. It is neither trivial nor absolute. What has not been proven by the supplied findings? That the system will never generate an unsupported output in production. That unit tests have failed at a named company. That one testing technique is categorically insufficient in every implementation. Or that action-oriented agents are currently causing documented harm. Those would require evidence we do not have. The defensible conclusion is more useful than the dramatic one. Test coverage alone is an incomplete reliability story for AI that may influence decisions. Passing tests should increase confidence within the boundaries they actually examine. They should not erase the distinction between observed behavior and assumed future behavior. So, in the next release review, keep the green status. Then place two questions beside it. Which behaviors do these tests cover? Which reliability claims remain unverified? Ask whether the language used to approve the release matches the evidence the suite produced. That does not weaken testing. It makes testing legible. It lets engineers say what they know, what they inferred, and what remains open without pretending those categories are interchangeable. As AI moves from summarizing information toward identifying opportunities, explaining trends, and recommending actions, precision about evidence becomes part of responsible engineering judgment. Separate the cases that were checked from the contexts that were assumed. Separate a plausible concern from a documented incident, and separate a passing test from a promise it was never designed to make. If you want more evidence-conscious deep dives into AI and software engineering, Subscribe to Neural Stack. In the comments, share the exact sentence your team uses when a release passes its tests. Does that sentence describe what was checked, or does it quietly promise something larger?